All right. Welcome everyone to the Cleveland R user group. We're very happy to have Angus Mitchell here from Austin, and he's going to tell us about his experience being both an R user and also a data engineer deploying R. So thank you so much for being here, Angus, and take it away.
Thank you, John. Okay, so like John said, I'm a data engineer. Um, my initial background was in sports analytics, but then I've sort of specialized more so in data engineering, and I've been doing that for the past couple years. And I've just gotten a chance to do this to build this R system, like the same one, three different times. And there's just not many chances I feel like that you have to get three shots at the same thing. Like normally when you screw it up the first time, it's dead. So it was just a good learning opportunity. And I mean, me selfishly, like I'm kind of trying to learn like what else is out there in the art community. So I'm curious to hear from you guys, sort of I don't know what sort of ideas this provokes. But the talk's about 30 minutes, which should leave like plenty of time for discussion afterwards. Okay, so the TLDR on like the three times is like the first time around, it was sort of like inmates running the asylum, like the R people were doing all their stuff. We scaled, created all these issues for me, the data engineer, and then the second time was like me instituting reform and I took out my revenge in the form of various software tools on all the R people and they were not super happy. And then we got a third shot at this a couple years later down the road, and we had a chance to kind of step back, talk about it, and then I think the third time around, we've found something that's closer to the best of both worlds. I think has worked out pretty well so far. Okay, background. So one of the things I've learned is that when you talk about like in production or data science, or it's like these terms are like so overloaded, um, that you really have to provide a lot of context to have like any sort of conversation. Like if you're just throwing out takes, this tool, that tool, you just end up with like people arguing with each other and basically talking past each other because they're not defining stuff correctly. So pretty much like the entire talk is like context and background, just to explain like what was going on that sort of, led to this like one decision that we made. Um, and so I can sort of start with like what I was doing before these three times and sort of like my initial introduction to R and like data science in general. Um, when I was in college, I read Moneyball. I don't know if any of you guys have read it, but I was, inspired by this and was like, okay, could I do this as a job maybe? I was not a baseball guy. I was a basketball guy. And so, wanted to do this in basketball. And so I graduated in 2013 and it was this good little window where like Moneyball, the movie had come out in 2011. So, like all the people who didn't have like Moneyball analysts were all of a sudden like, oh shit, like we gotta hire like a Moneyball guy. Um, but then it was before, let's say like 2015 when the Warriors became really good and the three-point revolution sort of started. And then at that point, like the analytics movement was really off to the races. So like I sort of came in this window where teams were starting to hire, but it wasn't super well defined. And yeah, I don't know. Like it wasn't nearly as structured or like competitive also as it is now. Like now, like all the kids I see applying to these jobs are like so smart. Like they're all freaks, like it's crazy. So anyway, the way I went about this was like I went to summer league, which I don't know if you're familiar with this, but it's like over the summer there's like this tournament in Vegas, and you can see there's not a lot of people there, and like a lot of the people sitting in the stands just work for NBA teams. I just like went to these games and like went up to people and talked to them and gave them my resume. It was honestly like pretty terrible. Just like lots of cold conversations, but also like pretty effective. Ended up getting some interviews and I got this job with the Charlotte Hornets. So if you're wondering what it looks like to work in the NBA, this is how I'd come to work every day. And then there's like behind this, like you can't really see it's like off to the left, but there's like a door sort of behind this hot dog stand. And then we had like there was like effectively like a closet behind this hot dog stand with like three cubicles in it, and that was our office. And so we were crunching the numbers. Um and so yeah, so I used R. I mostly used R at this point for just like visualizations, like graphing, creating PDFs, things like that. Like this is just an example. It's like, okay, for each year, sort of looking at each draft position, like how good of a career did each guy have? Um, so you can see like most of the best players are drafted like 1 through 3, but then also there's a lot of randomness in the draft too. Okay, and go back to that like initial question of like defining stuff. So I was doing analytics, but it's like, what does analytics even mean? Basically, we were just answering simple questions for the coaching staff. This is Steve Clifford, he was the head coach, and then the general manager who does like trades and signings and like draft picks and things like that. And so you can kind of imagine like coming into a company that has been running on pen and paper for the past 30 years, whatever, like what that job might look like. I mean, a lot of it was just like digitizing things so that we could like run a SQL query and get some like simple answers to pretty simple questions. Today things are a lot more advanced, but this was sort of the early days. And so at that point in time, I honestly never used the words like in production. We had this internal web app. It was, if you ever used basketball reference, it was sort of like like an internal version of that. It's like there'd be like player pages and we'd have our like proprietary stats on players and things like that. And then we do some automated reports. So like before a game, the coaching staff would get this automated PDF. And then there's also these like before the draft, I would just call them periodic reports. Like for the draft, everyone would come into town, we'd all sit down, we'd talk about players, and everyone would have like this big book of information. And there'd be like a page that's like, what does the analytics say about this guy? Um, and so yeah, so that was kind of like my first, it was sort of like the first like inkling of I don't know, just yeah, what does it mean to productionize something? I don't know. What's it like to use R, et cetera, et cetera. But all just be very fundamental at that point. Okay, so then anyway, next chapter, a couple years down the line, I went and worked for this company called Big League Advance. Um, if you're into baseball, their main line of business is like they basically do like venture capital for minor league baseball players. Um, I don't remember, I don't know who on the Guardians would be like one of their clients who'd be publicly available. But like I don't know, they've signed some good guys. So they're doing well on that front. But but what I was doing is like they started like this sports gambling operation. And so um me and like another data scientist were initially like the first people hired for that. So it was like me and this other guy. And when I was at the Hornets, I mean, like I said, going back here, like I didn't have a super defined skill set. Like I was doing everything from like web app development, like, data pipelines to like ad hoc analysis to just like, Excel stuff. And so I came into this job not really having a super well-defined skill set. But then the other guy that I worked with was like he was just much more experienced on the predictive modeling side and just much less comfortable doing any sort of software engineering stuff. So I sort of ended up drifting into like what now I would call it data engineer. At that point in time, I didn't call it that. But basically it's like DevOps, database development, ETL development. Um, and I think we put the data engineer label on that after we sort of figured out that that was a thing. Um, okay, so in production this time around, so the product was like a it was like a trading dashboard for like a trader to place sports bets. So you can sort of imagine what this is just a random screenshot of like a trading dashboard, but our thing looked, something like this, where it's like you've got, kind of like it's like a bunch of different like little visualizations, tables, sort of everything else like squished onto a screen. And and you can sort of imagine like what like the back end of that looked like too. Like we're pulling in sports data, the results of games, the schedule for upcoming games, like yada yada yada. Then data scientists are building models, and those things are spitting out various predictions that then get fed to the trader, and the trader's sort of using that um, to hopefully make intelligent trades. And so okay, like characteristics of this system that, are likely to be maybe different from like where you work or what you do. Like like one of the ways I think about in production, it means so many different things, but it's like I think one way is like, okay, what does it take to get the code to a point where it's like making money for the company, or alternatively, like getting it to a point where like if it breaks, then the company is like losing money. And so like in this case, I would say that, you know, it was sort of a system where like the worst thing that could happen would be to like confidently make a really bad prediction. Um, like it was actually okay to say like, hey, the system's broken, or we don't know what the prediction is, or something like that. But to make like a really bad prediction is really bad. So this is like a system that well, another thing I'll say is like another big source of complexity was just like all the different data sources that we were pulling in. And when you're reliant on like scraping a lot of data from random websites, and also there's sort of some chaos in the data that you're scraping. It's like every once in a while like a game gets canceled, or I don't know, it just goes to like six overtimes, and like it goes later than like your scraper starts the night before or whatever. Things tend to break. So it's sort of a system where like inherently things were expected to be breaking all the time. That was fine. Um, like I said, like we just didn't want to put out like really confident bad predictions. So like it was just sort of like things were constantly breaking. We were constantly fixing them. And there's sort of like this constant loop of like, okay, let's make the predictions better. Let's talk to the traders. Let's make the predictions better. I don't think there's like a term for this. I would call it real-time operational. It's sort of like this system where you're sort of always sort of juggling these balls and trying to keep them in the air. Um, but I think that had like pretty important consequences for some of the decisions and like what worked well and what didn't as we got into this thing. Okay, so the first attempt, if you remember from my first slide, this is like the inmates running the asylum part. So when we first started out, the data scientist, this guy on the left, he's just working on his laptop. Like we hadn't like no one was like making any trades yet. This is sort of like the R&D stage. Then like I was just setting up this database, and then he'd like make predictions and write them to the database. It's good. And then I would like, sort of handle like, feeding them to whatever other like systems needed to work. Um, we outgrew this for two reasons. One was that we needed more memory. So like some of these models would just take like, I don't know, they would consume like 40 gigabytes or something like that. So this was not like a big data problem. And you guys would know more about the modeling specifics than I would, but I think it was like, I mean, it was just like parametric models and spitting out like predictions, and maybe there are ways to optimize it and to like get it lower than that, but the simple answer for us was like we're running out of memory and like the laptop isn't great. The other thing was that we had these scheduled jobs that would run at like 2 in the morning, and the data scientist laptop like was not really like an ideal server for us to be building this system on. So the sort of initial migration was like we set up this VM on EC2 and it was running RStudio server. And if you haven't used RStudio server, it is just RStudio, but it runs in your browser. And so this was like an awesome transition from here to here because like the only thing the data scientist had to do was like go from using RStudio as like a native desktop app to just using RStudio in his browser and like he was good to go. And then at that point in time, the way that we were productionizing stuff was just setting up cron jobs. So when he was like ready to like put something into production, like he would just set up a cron job on that machine. It would write to the database at 2 in the morning, and like we were good to go. These were the good old days. Okay, yeah. So then we grew. So then we hired like, I don't know, like six more data scientists or something. And some of them, I don't remember exactly why, but like we had more than six VMs. Everyone is sort of working in isolation, but this started to like create like some issues. So one was management all of a sudden was like, hey, like why are we spending like $10,000 a month on computers when like you guys were just working on your laptops a month ago? Um, and so that was a problem. And then also for me, like this was like total chaos. Like things would break. I would have no idea like which of the 10 VMs like the problem had occurred on. Um, it was just sort of chaos. Like if for the most part, like each data scientist sort of owned their own stuff, and that was good. But also, if someone was unreachable, it was very difficult to sort of figure out, what was going on with their stuff, how to fix it, how to rerun it, everything else. So it was sort of like this scattered mess that was like very difficult to get visibility on. Everything was like, nothing was like consolidated. The cost management part was hard. We're doing a lot of like machine management. Then we're like, cost management was hard. Then we're like, okay, let's try to like conserve the memory on these machines. But then like we do it too low. And then like the task would like exceed the memory and it would crash overnight. It was just a constant battle with this stuff. Um, Something else I should say though is that at this point in time we didn't have like a ton of issues with environment reproducibility. Like obviously being able to reproduce environments is good, all is even, but that was not like the main pain point by any means. Okay, so second time around, it's like, okay, we've got all these problems and basically AWS just like moving everything to like other services on AWS solves them. Like it solves the costs management. Like if you run stuff on like a serverless architecture and then it immediately spins down like as soon as the task is over, then you're not like you don't have like unutilized compute. Um, and then, we could have all of our like cron jobs and data pipelines in one consolidated place. We could have all of our logs in one consolidated place. It kind of solved like all the data engineering headaches that I was experiencing. So we implemented this and I was happy, management was happy. All the data scientists were like they just like hated it. It was like terrible. And I think part of the reason is like there are people they're not they're just sort of averse to like software engineering stuff and like Docker has a nice command line interface but like they were not super comfortable with that. um Another I think like just sort of I think that can be overcome with like okay, let's just sit down and learn this. Another actually like real issue is that like I said, this is sort of a system where like things were constantly breaking and we're sort of constantly like keeping all these balls in the air. And there like the Docker a just added complexity to like every single build cycle, just either in terms of time or a bug fix or something else. And so like before, there were just a lot of tight feedback loops on the data scientist side. Like something would break, they'd go fix it, boom, it's like ready to go, rerun it, very easy. Now it was like there were like multiple layers of tooling in between them and just getting something to run and like being able to rerun it and be able to see the logs. And that was really difficult for them. And then like the irony of this was that like this actually created like a bunch of second order headaches for me because before the data scientists could do a lot of their own work like by themselves end to end. Now like now they're coming to me like, hey, I can't figure out this Docker issue, or like, hey, like the way that the AWS console organizes logs is like super unintuitive. Like where's my output for this task? Or like, hey, did this stuff run? Like I can't figure out if this ran or not. And so yeah, it was like at the end of the day, like all my first order problems got solved, but then yeah, there were all these other issues. Once again, like sort of it's particular to like this setup and like the fact that we're keeping these balls in the air all the time. But there were all these other issues that like didn't work super well in our context. Okay, so then I ended up I left Big League Advance. A couple other people left as well, and then we sort of reunited down the road, and we got a chance to sort of step back and look at this whole thing together again. And one of the things that we realized was that Docker is in a lot of ways like this gateway drug to like all these shiny toys that exist on AWS. It's like it unlocks a lot of really nice cloud features. Um, but sort of on the flip side, like Docker really solves like the environment reproducibility problem. And that was like not a huge problem for us. Our data scientists were basically working in isolation. Um, it's not like they were spinning up like, you know, or let's just call it dozens of like little microservices or anything like that. Like they were kind of we just needed something that was like a little more powerful than like them running stuff on their laptop. A little more memory and like just, able to stay on 24/7. So yeah, so this Docker thing was sort of a puzzle. Just as sort of like a quick tangent on the history of Docker. It was invented by this suave French guy named Solomon, and he built it when he was building this company called Dot Cloud. Um, and Dot Cloud was like a hosting platform. So it's sort of like a competitor to like Heroku or some of the AWS services, something like that. Like basically like you hand Dot Cloud like some of your code and like they figure out how to host your app. Which is to say, like he was dealing like with the most concentrated version of this problem. It's like he has like I don't know how many customers he had, but let's just say, hundreds of customers, thousands, maybe tens of thousands of applications. And he's trying to figure out how to keep them all running. They all have different code bases, everything else. So it's like he was like the perfect person to see this problem and be like, oh, like there should be like this common abstraction around these things. At the same time, he's like dealing once again at this level of scale that is like thousands to tens of thousands of apps, which is like not just not the scale that we had, and we didn't really think through like from first principles, like okay, what problem is Docker really solving? We're just kind of like, yeah, like we'll just do the AWS thing. Okay, we got to Dockerize stuff, boom, 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 get it running. Um, And so, yeah, I don't know. I mean, I just thought the going back the second time, like I think the history of it just sort of helped us understand like some of the rationale for the tool in the first place. So anyway, our like whiteboarding session the third time around, I mean, basically looks something like this. We're like, okay, can we do it like R style and have like no Docker, just have like the data scientists basically work in like RStudio and Git, effectively just write the code, kind of like our setup from the first time. But then can we also get like the advantages that we got from the second time around, which is like data engineer friendliness? Like, can we get some visibility, pipelining, consolidated logs, scalable memory, that sort of thing. Um, and so what we did was we started back where we originally were, which is like, okay, let's get a VM that runs our studio server and you can work on that. Because like we know that was like a really good developer experience for this particular use case for this type of data scientist. And then let's just sort of slowly build like the data engineering stuff, which is once again is like being able to view logs, being able to set up pipelines, everything else, like on top of that. And so we just sort of slowly built this out as like a custom build, in a sort of very like janky, lightweight way. And I will also say, like, I think this is like a much more tenable option in 2026 with LLMs than it would have been in 2019, like the first time we were doing all this. Like I don't know, the ability to basically say like this is exactly what I want to do. Like, how do I do it is just so much further along now than it was then. Um, but anyway, it's been like it's been a good setup so far. Like the data scientists have just a very good developer experience. Like they build stuff locally. When they need to like productionize it, they just push to Git, and then it runs on this VM in AWS. If things break, they can go directly into the production environment and fix them on our studio server. In general, there's like not a lot of like challenges replicating the production environment. They use our env, and that has worked well for keeping things consistent. Um, and then we haven't had any issues with like system library mismatches or anything like that so far. And then from a data engineering point of view, we've kind of gotten all the features that we had in AWS. They're not as pretty or as nice, but it's been functional and it's pretty much taken me out of the loop on a lot of the stuff, which is kind of what we were going for in the first place. So yeah, let's see, how'd we do? 7:34. So yeah, so thanks.
Perfect. Yeah, thanks so much. That was fascinating. I think a lot about because I work with a lot of different people, like trying to put what's convenient for one group with on the other group, right? Like trying to find these collaboration between different silos, right? So that's why that to see that's the same thing over and over again, figure out okay, what do we need and what do you need? That was great.
Yeah,
I have a bunch of
it's
questions, but
it's
I'll leave it
challenging.
open. Go ahead. Or I could kick it off. What you said to that R, you didn't seem to have much problem with the R environment and the packages. So I'm curious, what are the core R libraries that your team uses that they're installing over and over again to use for these analyses?
Ooh, I am not I'm not like 100% sure on that. I think it's like Glimnet and like that type of stuff. It's a very high level like bad answer though. I
There's a
mean, I
lot
think
of
they
predictive
they use
modeling
all
though.
the kind of like I don't know, like like the tidyverse kind of like data wrangling stuff, but I think for like actual modeling, it's things like Glimnet. Um, is that
And
like is
yeah,
that I don't know, kind of giving
yeah,
any
excuse me. I
insight
mean,
at all?
clearly, whatever it is, it doesn't causing you many installation headaches. So I mean, it's a good sign that when you have the six data scientists all working together, the fact that installation stuff and environment stuff wasn't a big issue is a good thing. um,
Yeah, 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 for sure. And I mean, they were all. like I said, they all kind of worked in isolation. So it wasn't like we needed like one person's code to run on like another person's infrastructure.
Yeah.
So that also made things simpler. And like honestly, one of the challenges of like Dockerizing everything was it's like, okay, the simplest thing is probably just to have like a standard, like Rocker container for everyone.
Mhm.
But like now that container like it's either got to have the union of like everyone's packages, or we have to like figure out a way to do like everyone's build separately, which just now creates like a little more overhead in terms of like
Mhm.
each person's got their own container, sometimes multiple containers, and we gotta like track them. So yeah, I don't know, like that in of itself kind of created like a challenge too, as opposed to just like, hey, this is your computer, like you own it
Yeah.
and manage
That was
it.
kind of a unique part of your setup, though, too. Like for each of them, they just have to fetch the data from the database and then write their predictions, right? So it's like they could sort of, if it, when it ran on their laptop, fine, right? It doesn't really matter where it runs or how it runs, as long as the data, they can get the data and they can put it back, right? That's
Yeah,
that's sort of a nice
exactly.
aspect of
Exactly.
it. Is
Exactly.
um, um, any other questions?
So I know cloud is where everyone's at, but did an on-premises compute environment did that come up at all? Did you guys think about just hosting your own server locally?
You know, I've actually got there's another guy I know who was part of that group of six who's doing something else now. And he is actually, I don't think he's pulled the trigger on it, but I think he is probably gonna go down that route. Um, which I think is interesting. We didn't really, no, we didn't really consider it. I mean, it was sort of like we went from like the prototyping stage to just like effectively a second prototyping stage. And it's like, I just don't think we ever like had the confidence to be like, oh yes, this is exactly, 'cause we were also sort of like fleshing out like the business plan at the same time and like everything else. And so I don't think we had the confidence to be like a year from now, this is exactly what our workloads are going to look like. And so it was always sort of an advantage to like have that AWS infrastructure that you could just like throw away if you didn't need it. Um, I mean, as it works, like we ended up just spending a ton of money like renting computers, and like and like eventually we were like doing some of the we were like buying the AWS savings plans and things like that. Um, but yeah, at least like initially we didn't really we didn't look into that too much.
I could
Yeah,
definitely see that. I could definitely see that paying off, Alec. That's a good point, especially if they just leave them up. They just leave them spinning all that time because they don't want to shut them down. At some point, that's going to pay
Yeah.
off.
It is interesting though, like the math on because I mean, like I said, like my friend, he just ran the numbers and was like, yeah, like I think it's gonna be cheaper to buy like a server with like 100 gigs of RAM than it will be to like rent AWS stuff. But he's got like a pretty good idea of like this is what he's gonna build. This is how much like capacity he needs, everything else. So I don't know.
I'm curious about the website side of things. So so you were kind of managing the data. Did you have
Mhm.
another team that was deploying the website on a separate? Like, how did that?
So we had like a few different things. So for a while we used a tool called well, and there were like different there were kind of different sites too. Like some of the stuff, we had some interfaces that were dedicated to I guess like if you think of it as sort of like an assembly line, like the end result is like the trader dashboard and uh that thing, I think the first version of it we built with this tool called Retool. That's like it's like a drag and drop website builder for like internal facing apps. And then and then like the next iteration of that, we had like a contractor build a site. It was like a just like a pure JavaScript front end that just sort of needed to have like a contract with our back end, you know?
Mm-hmm.
Um, and then but then also there were like that's sort of the end, but we also sort of needed like visibility at like other points of the pipeline too. And so mostly for that we would use, like the logs and like AWS console and things like that. But we did have like some specific little websites for things in the middle, like data correction and I'm trying to think of like mapping, It's like we'd have like data sources. One of the things is like you've got like all these different player IDs in different systems and then that you're scraping and then you got to like line them all up with one another. And then there's like you can resolve 95% of them just by doing like a string comparison, but then you've got guys with duplicate names and then you've got there'd be like character encoding issues where like one guy would have like an accent on his E and another guy wouldn't. And so we'd have like a tool for just sort of quickly kind of like running through guys and like, resolving those like mapping issues.
Any other questions?
I mean, I have a question for y'all, which is like I'm just
Yeah.
curious how I guess just like what like data science and what in production like means, the
I mean,
places
to
that you
me,
guys
in
work.
production means it's always running, even when you're not doing it and someone else is relying on it. That's what it is to me. So it could be an internal tool as well.
Yeah.
But a lot of the code, like I run or someone else runs, it's they open up RStudio and then they run it, and that either works or didn't. Whereas to me, in
Yeah.
production is it's running on some server somewhere that anyone can go and hit it at any time, whether that be the middle of the night, and it's got to keep running, right, or give the right result. So that's my personal definition. So whether that's internal or external, it's sort of this autonomous running thing deployed somewhere.
Yeah. So is that like ad hoc or something that's running on a schedule or like all the above?
No, well, running on a schedule. That's a good point. So that's an intermediate. I guess that could be in production. Yeah, if it's running on a schedule and it's actually updating a database or something, yeah, that could work under that definition. It's something you're not pressing enter on. So yeah, I think that would count too. Yeah.
Yeah.
Anyone else want to add to that? Audrey, did you have a question?
Oh yeah, I do have a question. Um, so how do you pronounce your name? Is it Angus?
Yeah, Angus.
Angus. Okay, hi. Uh, I'm Ajay. So I'm really passionate about sports analytics and a shameless plug. If you look up our YouTube channel, I also presented something on Boston Celtics
Oh,
because that's
really?
the team I follow
Nice.
about how R and everything. So I'm curious to know how how was your experience working in Charlotte Hornets? What are different data points did you use for their data analysis? And did you work with their sports analytics team who manages how each player is doing each game and playoff? And how do you guys analyze the data?
Oh, my friend, the sports analytics team was me and one other guy.
Okay.
And then I guess we hired like a couple more. We were like it's a pretty small team in general. It was like we had like four analytics guys, I think four college scouts, one pro scout, and then the GM, and then like a salary cap guy. And then a little later we had like an assistant GM, Chad Buchanan, he's actually the Pacers GM now.
Yeah.
But yeah, I don't know. It's like well, what do you want to know about it, I guess? there's a
Just
lot of different directions I could go.
so I would say more into the statistic modeling, like how you used any linear regression, logistic regression kind of thing of each. If, for instance, I would say for Celtics, I know Jalen Brown is a not great free throw shooter, so that analytics team would, tell their coach, hey, Jalen Brown needs to do more free throw practice, or say Jason Tatum, his 2 point shooting or something, or his 3 point shooting is not great. What what needs to be done? So they would just consult the coach, hey, uh, how how to do it. Just because I know because Joe Mazzulla uh, is a good into the Celtics coach. He is a lot into analytics, and also the GM of Celtics, Brad Stevens. He loves analytics, and they
Yeah, yeah.
love data-driven decision making. So, is it something you guys used to do similar to that, or anything different? Do you
So, okay, so
do?
this was like a point in time when it was like just when the player tracking data was starting. And
Okay,
so for those of you who aren't familiar, like there's now there's like cameras in the roof of all the arenas and
correct.
they have like a computer vision system that tracks all the
Yeah,
players. And you get this data set that's like everyone's XY position. And I think you get XYZ on the ball. It's actually like more
correct.
sophisticated than this now. Now you get like a point cloud of like people's hands and stuff, I think. But but yeah, you get this time series, it's like 25 data points a second or something like that.
Yeah,
And we were like just I think at that point in time, like when I first started, the Rockets were the only team that paid for it. Then the NBA was like, okay, we're gonna buy this for all the teams.
yeah,
And then it's like we got it installed, and then at that point in time, we were just like we had these interns who like went to Davidson who would like drive down for every game, and they would sit and do QA on this thing. They would sit
wow,
at these laptops in the arena, and there would be like a picture that popped up that was like, is this Dwight Howard? And they'd be like, yes or no. For like 3 straight hours. And so that was just like the early days of like the data actually being collected. And then I mean, we had like no capacity to like do anything with it. It was like like we were getting this data
yeah,
feed from the NBA. Like it was a major project just to do the data
yeah,
cleaning. And there was actually this company like right around the time that I was leaving the Hornets, there was this company called Second Spectrum that had like sort of put together a product, but they had like 20 engineers, I think, put together this
yeah,
product that cleaned all the data and then was like, running. They were building like machine learning models to like
hmm,
algorithmically identify like, hey, this play was a pick and roll, and then they could sort of like they could sort of like chunk the data and be like, hey, this was like a pick and roll by Kemba Walker, and then they could sort of like start doing a lot of like interesting data extraction. But that was like as I was kind of on my way out the door.
mm,
And so like like when I was there, it was like there was like box score data. A lot of the box score models were like pretty rudimentary and like, it's like PER if you're familiar with that. Um it, the box score is just not like a really great um set of statistics for like identifying how good somebody like
hmm,
actually is at basketball.
yeah,
And so I mean, we didn't really do, to answer your question, like we did basically no predictive modeling. We were just doing like basic tech consulting. It was like the coaches had this process that was like pen and paper, and we're like putting it in a database, and then
I see.
we can give them like descriptive statistics on like, hey, like these are our best play calls, like these are our worst play calls. Um, and then we would just be like caveating everything with being like, just like this is a super small sample size. Like, please don't actually like make a decision based on this. Like
Hmm.
that was like
Yeah,
the job basically. Just like delivering like super small
hmm,
sample size statistics and being like, don't actually do anything with this. Thank you. Like,
I see.
so.
Amazing how things
Uh,
change in just like a decade.
Yeah.
yeah. So, yeah, I'm trying to think of what else. Like at that point, I think like the real plus minus stuff was like publicly available. That's
Yeah.
like that's like a pretty good one number metric. But yeah, I don't know. We were mostly doing like I said, like just basic tech consulting, and then we did like some of our own like proprietary player tracking too. Like for prospects, we'd have like people watch them and like chart defensive statistics that we cared about and stuff like that. So
Yeah. Nice.
a lot of the like really unsexy stuff.
Mhm. Yeah. So do you still are you still working in the sports industry at the moment or
No, I'm
no?
not. I still I just kind of burned out on basketball. It was like I remember talking to this guy at Summer League, and he was like, "Do you like basketball?" And I was like, "Yes, obviously I like basketball." He's like, "No, no, do you really like basketball?" I was like, "I think so."
Mhm.
And then yeah, I don't know, you watch like 300 basketball games a year by yourself and you're like, maybe I don't like it as much as I thought I did. So, I still play all the time. Like I love playing, but
Yeah.
I don't and you know, I watch like with my friends and stuff, but I'm not the junkie that I used to be.
Mm. Yeah.
I don't know. Do
Thank
you follow you said you follow the Celtics?
yeah, I do. Mhm.
What about the rest of y'all? Do y'all follow sports at all? I saw you had a that guy from the Guardians gave a talk, right?
Yes, that was a cool talk. I put that in the chat too. So that was an awesome chat, awesome talk. I do not follow sports though, so I'm not the person to chit chat about anything about
Yeah.
that.
Yeah, me neither, unfortunately.
Yeah, Ajay's our sports guy, at least
Yeah.
basketball. Do you follow any other
Yeah.
sports, Ajay, or just basketball?
No, I mean all sports,
Yeah,
from
okay. You'll be our
football
resident sports
to
ex.
football, ice hockey, baseball, and of course,
Yeah,
from where I am, cricket is very popular as well. So
Nice.
yeah, yeah, that's because analytics is getting really big because even the universities they have a major apparently sports analytics. Just so you know,
wow,
yeah, in Akron and other universities they're starting uh, like a degree in sports analytics or a major.
wow, that's
And
cool.
people students can sign up and yeah,
Do you
they
know
can.
what department it is? It like in the math and
Then
stats department, kind of,
no,
or
it's
is it
under
like
business. At
under
least in
business?
Akron,
That
yeah,
one to me, I'm like,
yeah,
I don't know if the job market can support that.
yeah.
I
At
don't
least
know.
in
We'll
Akron,
see.
it's under business, but I think at the universities it can be under different departments.
Mhm.
Yeah.
Yeah. Yeah. It was a good, I mean, it got me like interested in my major for sure after 4 years of just kind of, you know, I don't know, just clocking in, clocking out. So
Yeah.
it's cool from that point of view.
Mhm.
What was the most impactful project on the decision making of a sports team that you've witnessed? And are you allowed to speak about that at all?
It's like, oh man, I mean, it's a good question. So like there's this article about the Houston Astros that was in I can't remember what publication it was in. This was like it was like The Athletic or something. This was like 5 years ago. And it was talking about how they they were scouting. instead of scouting like a pitcher's like overall performance, what they were doing is they were scouting their performance by pitch type. So like they would scout their performance based on like their fastball, also their curveball, everything else. And then they would, and what they sort of realized was that like teams were having a lot of pitchers just throw like a very suboptimal combination of these pitches. So like you'd have this guy who's got like an amazing fastball and like a really bad curveball, and he's throwing like 50% fastballs, 50% curveballs. And so what they did was like they just signed these guys and they were like, hey, like you're literally never gonna throw a curveball again. Like you're just gonna throw fastballs. And the article was like, oh, like these, like the tone of the article is like these guys are they're geniuses. Like they have a guy who literally worked at NASA before, like these are literal rocket scientists. And like I can tell you with complete certainty, like every team, every baseball team has analysts who are capable of like making those sorts of insights. And I would say like a lot of the teams were probably evaluating pitchers in the same way. And like by far the biggest difference was um like the sort of like organizational capacity for like leadership to be like, okay, analysts, like we got this information. Like also now we're gonna like implement it and like our whole scouting org is gonna work this way and like everything else. And so like there's a lot of things on like the decision making side that just like die on the vine in sports and like it's I mean I know it's true in like every industry but it's probably like doubly true in sports where there's no profit motive so if you're poorly managed you don't go out of business you just like have a bad team and continue to charge your fans for tickets and jerseys but yeah, to answer your question, it was just like a couple like random trades that were like proposed and we were like, no, like don't do this. And then and like there was like no analysis involved. You know what I mean? We're just like, please, like please, please, like don't do this. Like, like jumping up on the table and like pounding our fists. And then I don't know, in terms of like the actual analysis, I don't know. It's just sort of a mixed bag. I think like the defensive tracking stuff we did was like probably uh like the most interesting. That to me was like I think probably like the highest alpha stuff that we did just because it was like a completely novel data set that like we worked like really hard to put together. Um but then like did that translate into like amazing decisions? I don't know.
What
So
do you mean by defense tracking? Were you using the 3D information, or what does that mean? Defense
no, no,
tracking.
no. So we just had people watch we just had like this team of interns like watch tape on like a bunch of prospects and then I don't remember exactly they would chart basically on every possession like who they were guarding um like what the play type was and then like what the result of the play was and so then we got a data set that was like it's basically like, okay, here's the guy that like he was guarding on every possession. So you could sort of say like, okay, on average, like he reduced his like opponent's field goal percentage by, 10% or something like that. We could account for like the quality of the competition. Um, and that was just interesting because like there were some guys like defense is such a reputation based thing, or like it was at that point in time. It's just like a guy is, it's like Moneyball the movie. It's like a guy like looks he like is like intense and like he just looks really athletic and everyone's just like, oh man, that guy's like an amazing defender. And then you look at the stats and you're like, wait, like this guy's actually like terrible at defense. And then there's some other guy who's like kind of goofy looking and you're like, wait, this guy's like the best defender in the country? Like what? And so um yeah, I don't know. I mean simple stuff. And stuff also that now I think with the 3D tracking data, well, I don't know to what extent they have it in college. In the NBA, they can source that the sort of stuff pretty easily. I don't know exactly what the status of that stuff is for college tape, but
All right. Well, we're at the hour. Any last minute questions? All right. Well, we'll stop it there. Thanks so much, Angus. This was really informative, both the sports analytics and also the data engineering side. And so we'll be getting this up on our YouTube channel and sharing it with everyone. So yeah, thanks, and I'll hope to see y'all soon.
for sure, it was nice to meet y'all.
Yeah, thank
Enjoy
you,
the greater
Angus.
Cleveland area. I'll see y'all later.
Yeah, see you, Angus.